So we're going to start solving polynomial equations algebraically. We just got done with solving them graphically. The idea is the same with quadratics that we did a couple months ago or whenever that was. So when we were graphing them, we were just looking for where the line crosses the x-axis. And, just like anything else that you graph, that has its benefits and its problems. Benefit being that it's quick, problem being it's not very accurate. So we're on page 263 here. And, it just says that just like some quadratics, you can solve some polynomials of higher degree, 3, 4, 5, etc., by factoring. And if we can factor it, we can set those factors equal to 0 and actually find the the x-axis intersections. Sometimes you cannot factor it, and this is what they're saying here. It cannot be written as a product of two polynomials. And in that case where you cannot factor it, it's called a prime polynomial. And just like prime numbers, that means that the only factors of this polynomial are 1 and itself, that polynomial. Okay, so basically all we're doing is a little bit of factoring today. And then we'll do one little more step after that. And so most of this is review. The only thing that we haven't talked about yet is the sum and difference of cubes. Now, the sum and difference of cubes, first you have to be able to identify them. They're going to have two terms, and the two terms have to be perfect cubes. So can you or can you not take the cube root of these? And if you can, then you can factor them in this case. Now, unlike other factoring, the only way to factor sums of cubes and differences of cubes is to memorize this formula. Okay, and it looks like there's two formulas, but if you notice, the only thing different between these two is that the signs change. Okay, or well, is that they're different. It's not that they change, it's just that they're different. So really, all you're doing is memorizing one of these formulas, and after that, you are going to use this acronym called SOAP. And so the SOAP refers to the signs here. So if we're doing positive, so the sum of two cubes, notice that the sign is the same, plus and plus. If we were subtracting, it would be minus and minus. The next sign is always opposite of what you start with. So here's a plus, and now it's a minus. Here's a minus, now it's a plus. And the last sign is always positive, always positive. So same sign, opposite sign, always positive, and we're referring to what it starts with. So really, you're only memorizing this once, and then you're thinking of SOAP. And so this isn't so bad. And so when we get to it, I'll go through an example, and I'll show you how I do it. And it's really not that bad. You just got to spend a couple minutes memorizing that, and then if you just do a few problems, it won't be that big a deal. So like I was saying, basically all we're doing is factoring today, just with a little bit of a new twist when we deal with the sum and difference of cubes. And now if you remember, when we were going through the factoring, I said basically you're going to count terms and determine what to do from there. And one of the things that they mention up here, which I strongly suggest you try to remember, is that you should always be looking for the greatest common factor first, okay, and then going through all these steps. And so like this side is kind of confusing. And so, I wouldn't go about memorizing any of these formulas except for the sum and difference of cubes. Okay, everything else we kind of have a little pattern to go through. But always check the greatest common factor first. Then if you have two terms, check to see if it's a sum or difference of cubes. Oh, these two, sorry. Or see if it's the difference of squares. Okay, and so, again, we'll do a couple of these so that you feel a little bit more comfortable with it. And then if there's three terms, this is the A times C method. Again, I wouldn't memorize what they're giving you here. I would just say, oh, look, there's three terms. I've already taken out my greatest common factor, A times C method. If there's four terms, and they say or more, but I don't think we'll do any of the more. Just so 4 terms, you group the first 2 and the last 2 and see if you can keep factoring. Now, one of the things that's going to happen since we don't have a quadratic right away is that there may be more than just one step of factoring, and we'll see that as we go. All right, so we flip the page over, and the very first thing is the sum and difference of cubes. Okay, so I'm going to do this off to the side, and then we can fill this in, and I'll show you how I go about it. It's very similar to the way they go about it. I just kind of write it a little bit differently. And so what they're saying is, basically the first step is to say, can I take the cube root of each of these terms? And so then they're writing it out. And again, I'll show you what I do with this. So they say, okay, well, the cube root of 8x cubed is really 2x. And then we would cube it. So then the cube root of 125y to the 12th is really 5y to the 4th. All right, so then they go through it. Now I'm gonna show you what I do with this thing. So here's our original, 8x cubed plus 125y to the 4th. Okay, so I know we need some a's and b's and c's. So this is my a cubed. And I'm saying a cubed because that's referring to the formula. And this is my b cubed. So now I know that I need an a, and we just did this on this step. So my a would be the cube root of 8x cubed, so 2x. My b would be the cube root of 125y to the 12th. This is supposed to be a 12. Which would be 5y to the 4th, right? We just did that. The book did it basically the same way. So now I like to just write out what everything is, because I know I'm going to need an a squared, because I know the formula. So a squared should be 4x squared. And I know I'm going to need a b squared, so that's 25y to the 8th. So now I have all of the terms I need. And again, you just got to memorize that formula. I have it memorized already. So you got to have it memorized. And so this factors into the a and the b. The a squared, and again, I'm just going off the formula, a times b, so I'm going to write it as 2x times 5y to the 4th, and then b squared, 25y to the 8th. And now all we're doing is worrying about our signs, because even if this was subtraction, we do this part the same way. And so now I'm using SOAP. So that's the same sign. So we started with a plus, so the same sign is a plus. Opposite sign, so now we're at a negative. And then this last one is always going to be positive. Okay, and so then the final answer here, to simplify it, is 10xy to the 4th, and then everything else is basically the same. Okay, so I like to write this part out because that has all the information I need, and then I just have the formula memorized. Okay, so then what they need here, what are they looking for? So they got 2, so then they need a 4x squared here. And then a 25y to the 8th. Okay, so again, you just got to memorize that formula. Okay, and so they give us another one, and it looks like maybe you can't do anything, but if you pay attention, and you always need to check for greatest common factor, we can take a 2x squared out of everything. And then we're left with 2 terms that you can take the cube root of. So I'm just going to take those 2 terms off to the side and go through it again. So 27x cubed and 64y cubed. Okay, so again, the way I think about it is this is my a cubed from the formula. This is my b cubed from the formula. I know I need an a, So I'm going to take the cube root of 27, which is 3, cube root of x cubed, which is x. And I also need a b, that's part of the formula. The cube root of 64 is 4, and then the cube root of y cubed is y. The formula also says I need an a squared, so that's going to be 9x squared, and I'm going to need a b squared, so 16y squared. Again, I have everything I need now to get this factored all the way. So then I don't worry about my signs yet. I just know there's an a and a b, so a 3x. That's not going to be, I'm not going to have enough room here. All right, so then it's going to be a 3x and a 4y. The formula says I do a squared next, so 9x squared. Then I got to multiply a and b together, so 3x times 4y, and then a b squared at the end. Okay, so now I'm using SOAP. So same sign, opposite sign, always positive. So the final factored form here, 3x minus 4y, 9x squared, plus 12xy, plus 16y squared. Okay, and so then to jump back into what they got, right, there's the greatest common factor they took out. 3x minus 4y, 9x squared plus 12xy, and then plus 16y squared. Okay. All right, so now it's just more factoring. I said that they weren't going to give us more than 4 terms, but it looks like they gave us more than 4 terms. So we do have to try to group and change this into a greatest common factor problem. Okay, so this just takes a little bit of practice, but they say, okay, well, let's look at the first 3 terms. And is there a greatest common factor in that? And sure enough, 14, 28, and 35, we can all take a 7 out of that one. And then also there's an x squared that we can get out of that. All right, so what times 7x squared gives you 14ax squared? 2a. What times 7x squared gives you 28bx squared? 4b. What times 7x squared gives you negative 35cx cubed? Negative 5c. Okay, and so then we go to the next one. They have taken out a negative, which is a good idea. But what comes out of 8, 16, and 20? So they take out a negative 4y. And notice that they have the same thing left over. So then the idea is that this step is now a greatest common factor problem. And what we're taking out is the common factor of 2a plus 4b minus 5c. And what's left over? That's 7x squared and the minus 4y. Now, oftentimes they give this to you in order, but you notice that we had to rearrange this a little bit to get all the terms into the right spot. So this is just going to take a little bit of getting used to on how to rearrange it to make sense. But you should be grouping these so that the greatest common factor makes sense. As you look at this one, right, we had an x squared here, an x squared here, and an x squared there. So that made up our greatest common factor grouping. Then we had a y here, and a y here. So that makes up our other greatest common factor grouping. Again, it just takes a little bit of time to get used to. So now we're going to have multiple steps of factoring. And this is what happens when you get the degrees or the exponent's bigger than 2, is you possibly can have more steps. All right, and so they're saying, oh, look, this starts out as a difference of squares problem. And so they say, well, the square root of 64 is 8. The square root of x to the 6 is x cubed. And the square root of y to the 6 is y cubed. Sorry about I don't know why this, I can never get this to focus on these. I don't know if it's too dark in here or something. Okay, and so then they're saying, okay, well then the difference of squares works like this. And we never wrote it out like this. We just said, oh, what's the square root of 64? It's 8. What's the square root of x to the 6? It's x cubed. So you got an 8x cubed here and 8x cubed here. What's the square root of y to the 6? Well, it's y cubed. So you get a y cubed here and here. One gets a plus, one gets a minus. But then they say, oh, look, we now have a sum of cubes and a difference of cubes. So again, I'm going to go through on how I do it. So we got 8x cubed plus y cubed. So again, this is my a cubed from the formula. This is my b cubed from the formula. I need an a. So the cube root of 8 is 2. Cube root of x cubed is x. I need a b, which is y. I also need an a squared. So I square a for 4x squared. And I need a b squared, so y squared. All right, and so really, since we're kind of doing two things at once here. But all of these a's and b's are the same for both of them. The only thing that's different is going to be the signs. Again, this is where we're going to use SOAP. So this first one is going to be a and b. And of course, this one will be a and b. Then we need an a squared. We need an a times b, so 2xy. And then we need a b squared for y squared. Okay, and again, we're actually already doing this one as well. All right, so now we're just worried about the signs. So the same sign here is plus. The opposite sign on this one is minus. And this is always going to be positive. Same sign, opposite sign, always positive. All right, so then they got it written on two different lines here. So I'm just going to jump down to what I did. So 4x squared minus 2x. So what was my b was y. So this should be 2x plus y. And 2x minus y. And then it's 4x squared. One's a minus, one's a plus. Sorry about the blurriness. So then it's 2xy and 2xy. All right. So it just takes a little bit of practice to get that thing memorized. It's not that bad. Okay. And so now solving a polynomial equation by factoring, just like we did with quadratics, once you get them factored, then you can set them, both of those factors equal to 0. Notice that we do have to start off getting it set equal to 0. Okay, so if it's not already like this, you got to move terms over. Okay, but now we have 4 terms. We should check for a greatest common factor in all of the terms. I don't see one. Okay, so then we're going to group the first 2 together and the last 2 together. Much easier than that other one. Okay, because it's in descending order. There's only one variable. Okay, so once you start grouping, what you're doing is factoring out the greatest common factor from each of your groupings. So what comes out of, biggest thing comes out of 4x cubed and 12x squared. Should be a 4x. All right, what's the biggest thing that's coming out of the negative 9x and the negative 27? Well, it's going to be a negative 9. Oops, that's a 4x squared, sorry. Okay, so now it's a greatest common factor problem. We have an x plus 3 that we can take out, and we're left with a 4x squared and then negative 9. But since we started with a bigger exponent than 2, you always got to check. Because if you notice, this is now difference of squares. And how do I know that? Well, there's two terms being subtracted, and I can take the square root of both of those terms. All right, so a couple things to keep straight. Square root of 4x squared is 2x. So we got 2x there and a 2x there. The square root of 9 is 3, so we got a 3 there and a 3 there. One gets a plus, one gets a minus. So now we have as factored as we can get. We set each of these factors equal to 0. And then we solve. So I'm going to start over here, subtract 3. So negative 3 is one of those answers. On this one, I'm going to add 3. So 2x equals 3. And then I'm going to divide by 2. So then 3 halves. Right, I'm just solving for this variable. So then the solutions are negative 3 halves, 3 halves, and negative 3. So let's do one more of these checks. We'll do this check together. All right. So then, again, it's in descending order. So I'm going to try to group them, first two and last two. By the way, it's something we talked about a week or two ago. Right? We're looking for this many solutions. The biggest exponent is telling you how many solutions we're looking for. I'm looking at this, and I can take out an x squared. So if I take an x squared out of that, I'm left with an x plus 4. And then out of the next two, I can take a negative 25 out. And I'm left with an x plus 4. Now I have a greatest common factor in each of these terms of an x plus 4. I'm left with an x squared minus 25. Okay, this one is done. This one we can actually factor again because it's difference of squares. So then it's going to be the x plus 4. The square root of x squared is x. The square root of 25 is 5. One gets a plus, one gets a minus. We still have them set equal to 0. Now we can set each of these factors equal to 0. So then our answers are x equals negative 4, x equals negative 5, and x equals positive 5. So negative 5, negative 4, and 5. Okay? So basically all we're doing is just factoring plus solving a little bit, which is factoring and setting those factors equal to 0. So that should get you 1 to 15 odd on page 267. Tomorrow I'll go over whatever we need to make you feel comfortable with that.